Welcome class. Today we're going to have our first lesson in regard to some basic chemistry terms. The learning goal is on the board. We want you to be able to define basic chemistry terms. We're going to focus on that today. Ultimately, converting and calculating quantities, expressing these quantities in the correct number of significant digits, classifying matter, and then discussing properties and changes of matter. And that will be our overarching learning goal for this entire chapter. Today our focus is going to be on basic chemistry terms. A lot of them we talked about yesterday when we played Plickers. So I posted your notes on Edline, and I see most of you have them on your desk, which is great. And we're going to review some basic terms. We know that the study of the composition, structure, properties, and reactions of matter is known as chemistry. And you'll see that definition on your first quiz. Your first quiz is scheduled for next Monday. You'll also see it as the first question on your test. Now, anything that has mass and occupies space is known as, yes, that is correct, excellent, and that is matter. So matter is anything that has mass and occupies space. So we've introduced a new term, and the word mass and occupying space is in there, so we want to be comfortable with those terms as well. And the quantity of matter in the object, that is how much you have, is known as, yes, excellent, mass. So that's the quantity of matter. And typically we're going to measure mass using an electronic balance in here. Maybe in middle school you use triple beam balances, but we are going to use electronic balances, and you'll have the opportunity to use them in your first lab, which we'll be doing next week. When we use a balance in here, our unit will be grams, unless you really had very small quantities, perhaps like milligram quantities in medication, then you might be using a balance that was a little more sensitive and could measure milligram quantities. But for us, the unit will be grams. Now, interestingly, the fundamental unit for mass is the kilogram, and we'll come back to that concept in just a little bit. Now, mass and weight do differ. Your mass here and your mass on the moon is the same, but weight is gravity dependent. So what you weigh here is not what you weigh on the moon, and that's why they have moon suits when they go in outer space. And I highly recommend Apollo 13 if you've never seen it. It's an excellent movie. It'll keep you on the edge of your seat, and you'll see that moon suit link that we mentioned here. Now, the space the object occupies is known as, excellent, volume. Volume is the space the object occupies. And when we talk about volume, when we're doing measurements, there are a number of different ways that you can measure volume. For example, if you have a regular solid might be something like a rectangular prism, where if you had a rectangular prism, the length, the width, the height, how could you determine volume of that rectangular prism? Excellent. You could multiply those three variables, length times width times height, and if they had measurements of 4 centimeters, 1 centimeter, and 2 centimeters respectively, your volume would be 8 centimeters cubed. And again, the cubed because you add the exponents when the units are the same, so centimeters cubed. So that would be the volume of a regular solid. Note centimeters cubed as a possible unit for volume. Now, if you have an irregular solid, what would an irregular solid be? Excellent. Something that didn't have the same type of defined shape. Maybe you had something like that, three-dimensional, or perhaps you were looking at a penny, and I'll draw this penny a little bit larger so that you can clearly see certain measurements. For example, if that's a penny, the volume of a cylinder is pi r squared h, so you would have the height, and it would be very tricky to get the height or the radius of a penny, but you could, although your precision would be low. So instead of determining the volume of a penny in this regard, we use a technique known as water displacement. And with water displacement, you can, as it sounds, displace water to determine the volume of your material. So this is a graduated cylinder. And let's say that you had 20 mils of water in that graduated cylinder. And if I were to put 5 pennies into the graduated cylinder, what would happen to the water level? Of course, it would rise. Excellent. And let's say that the water level rose to that green line and you got 22.1 mil. How would you determine the volume of the 5 pennies? Excellent. You would just subtract the two quantities and you have 2.1 mils. And that would be the volume of the 5 pennies. So you can get the volume of an irregular solid by water displacement, and that's what you'll be doing in the lab next week. So here the unit for volume is mils, and 1 mil is equal to 1 cubic centimeter. If you had very large objects and you were doing water displacement, you also could have a unit of liters for volume, and when you're working with liquids, these would be the units for volume as well. So volume is the space the object occupies, mass is how much matter you have. So looking here, let's take a minute. We want to classify the following to determine if they're matter. Take a minute to do this, pair and share. Okay, peanut butter, my least favorite food, is matter. Water, you are correct, is matter. Fish, you are correct, good job, matter. Light, no. Light is not matter. Garbage, yes, good job. Time, correct, that is not matter. Motion, you are correct, not matter. The human brain, of course, you've seen those shows where the ME opens up the head, takes the brain out, puts it on a balance to determine its mass. Carbon dioxide and air, yes, both of those are gases. I could exhale into a flask, and I could mass the flask before and after the exhale and determine the mass of the carbon dioxide I'm exhaling. Not only do you matter, you're classified as matter, and while your ideas are important, they are not classified as matter. A tree is matter, and energy is not matter. Energy does accompany chemical processes, but it's not classified as matter because it doesn't have mass and take up space. Questions? Okay, so physical states of matter. We're going to talk about solids, liquids, and gases. And all matter is made up of particles. And the way in which these particles are arranged determines whether you have a solid, liquid, or gas. Now, some substances, such as water, can exist in all three states of matter. Ice is water in the solid state. Liquid water, water in the liquid state, that's like drinking water. And water vapor is water in the gaseous state, and that's what you see with the humidity. The humidity in the air, you have water, and that's why it's so humid down here. It makes for nice curly hair. We're going to take a look at solids, liquids, and gases. The abbreviation of each one is in blue. We'll look at the properties, shape, volume, particle arrangement, and particle movement. And I'm going to go a little bit out of order here because the particle arrangement and movement is what determines shape. So for example, if we were to look at a water molecule, for example, water has a bent structure in which you have an oxygen atom bonded to two hydrogen atoms in a bent design. In the diagram you're going to see the oxygen will be in the middle and the hydrogens will be attached to it. This is a covalent compound, and shown on the screen now will be water in the solid phase. So you see a water molecule here where the oxygen is red and the hydrogens are white, and that bend structure, and these water molecules are vibrating but not moving or changing their location. So the particles are very, very arranged in a solid with minimal movement, just vibration. And that's what gives a solid its rigid structure. Water in the liquid state, the particle arrangement is less and there's more movement. And that's why a liquid will take on the shape of its container. You can see the molecules flow past one another. So the particle arrangement has decreased and the movement has increased when you go from solid to liquid. Water vapor, this would be water vapor in the atmosphere. You can see there's really no arrangement of the particles, and they are moving very, very quickly. This is like when the bell rings at the end of the day and everyone leaves. Everyone's moving really fast. They're excited because they're going home. Whereas your liquid would be more like a bell change. You leave one class to go to another. So the particle arrangement is decreasing, the movement's increasing, greater movement here. And with gases, not only do the molecules move quickly such that the gas takes on the shape of the container, it also occupies the entire space of the container such that the volume of the container is the volume of the gas. And that really sums up the shapes, the particle arrangement, and the particle movement. In regard to volume, we'll talk much more about volume of gases when we hit the third 9 weeks and we talk about gases. We have 2 really cool labs planned for our gas chapter, but you'll see that temperature and pressure greatly affect volume. You'll see the inverse relationship between volume and pressure. That is, if you increase the pressure, the volume's going to decrease, and that's what happens with bubble wrap, and we'll talk about that more in the third 9 weeks. I certainly don't want to overwhelm you at this point. You won't really see changes in volume for solids and liquids when you alter temperature or pressure, but you do see it with the gases. And this column here, or this row, shows you some examples of solids. We'll be using coins in the first lab. We'll talk about ionic substances in the second 9 weeks. Some liquids, mercury and bromine, 2 elements on the periodic table that are liquids. And then finally some examples of gases. Nitrogen gas, the chief component in air. Oxygen gas, what you need to inhale. Helium, what you suck out of balloons at parties to talk really high. Carbon dioxide, what you exhale. And chlorine gas. So examples of solids, liquids, and gases. So you just want an overview of the 3 physical states of matter. There is, of course, a 4th known as plasma. We're not going to focus on plasma right now, so we won't worry about it. Introductory chapters can be tricky because they cover so much information. So I really want to keep your stress at a minimum and focus on what's important. So in today's lesson, in regard to defining basic chemistry terms, you want to be familiar with matter, mass, volume. You may want to make a little Quizlet up for yourself. Units you use for mass and volume. Classifying different substances as whether they are matter or not. And finally, the different states of matter. Next time we'll get into qualitative and quantitative chemistry and introduce you to simple conversions. Questions? Yes, we will be classifying the different elements on the periodic table as solids, liquids, and gases. Absolutely. And no, you don't need to memorize the periodic table. You'll always have it. We're going to work with it a lot, so it's a good idea to get familiar with it. Okay, great lesson.